graph from the vertex form. Today we're going to graph from the intercept form. And you'll notice that the process as we go through it is very different, just like it was different from the standard form the day before. So let's first talk about this intercept form and what it is and why this is not going through the page. All right, these are examples of the intercept form. And I want you to think about, why do you think this is called the intercept form? And how would you recognize this form? Any thoughts why they would call this the intercept form? Okay, let me give you a little hint. Some books, instead of calling it the intercept form, they call it the factor form. Does that help you? Oh, yeah, these are already factored for us. Okay, these are already factored for us. That's why they call it factor form. And what do we do with factors when we're looking for things? When we're looking for our x-intercepts, we factor, set them up equals 0, and that's where we get our intercepts. So all of those factors can be turned into x-intercepts just by glancing, which is why some books call this the factor form. As a matter of fact, I also teach analysis, and that publisher calls this the factor form. Your book calls it the intercept form, or I may have those two words mixed up. I can't remember which book calls it which, and I will say it both ways, because both are in my head. So just know that factor form and intercept form are the same thing, because you can get intercepts from factors. So for example, if this is what they give me, this is the factor form, I can tell you right now what the x-intercepts are. So if my y equals 0, what are my x-intercepts? 2, 0, and negative 5, 0. Because remember, I would set this equal to 0 and solve for x. I would set this equal to 0 and solve for x. Okay. How about the second one? What are my x-intercepts on my second one? Negative 8, 0, and negative 2, 0. And on the last one, my x-intercepts are positive 0, positive 2, positive 3. Notice this, again, this negative 5 out here has nothing to do with what's in the parentheses. So don't think you have to distribute it before you find the factors or anything like that. Nope, nope. That's your A out front. Okay, so in this form, to graph from this form, you don't have to figure your x-intercepts at all, because they're staring at you. But vertex is going to be a little different, because the vertex is not staring at me. So let's see what we're going to do next. So look at that on your right-hand side of your foldable on the outside. And this is the factor / intercept form. And there's the example there. X minus p, x minus q, factor form. All right, so obviously we can find our intercept x-intercept very easy. Then how are we going to find the vertex from this form? I'm not going to use the negative b over 2a this because there is no negative b over 2a, because the a, b, and c comes from standard form. Your thoughts logically? Let's say I have a line of symmetry right here. One of my points would be here. Where would the other intercept have to be?
5.
The same distance away, right? Mm-hmm. So if I have these 2 points, and they have to be symmetrical around the line of symmetry, what can I do to find what's exactly between my 2 x-intercepts? How do you find the distance between 2 points? There, that's the slope. Okay, let me ask you an actual question. If I want to know the middle age between my age and your age, how would you figure that out?
Subtract.
Subtract.
The years.
And then what, though? I want to know the year in between. Divide by 2. You want to average. You would average your age and my age. The average would be the age in between, right? So I'm going to do the same here. I'm going to average P and Q. So for the line of symmetry, I'm going to add P and Q and divide by 2. And that's going to be the X of my line of symmetry.
Wait, so you don't have to switch the sign?
Yeah, we're going to switch the signs because remember these are factors, but the roots themselves or the x-intercepts themselves are P0 and Q0. When we do it with numbers, it'll make a lot more sense.
So I mean, so if it's -5 for P, it's just 5.
Yep.
And if it's positive 5, it's negative.
You know what? Let's do it with numbers. Let's do it with numbers here. And then real quick, so the vertex shares this, right, as its x value. So it's going to be that same formula for the x of the vertex. And then how will I find the y of the vertex? The p word. Plug it in. So we'll open your flap and we'll do an example inside, so it'll make a lot more sense when you have So let's open your flap and let's put a nice example in there for the backward form. Let's do y equals 2 parentheses, x equals 3 parentheses, x minus 4. Okay, so my x-intercepts, my y is going to be 0 and my x-intercepts, right? And if I were to set this equal to 0, what would my x be?
Negative 3 and 0.
Set this equal to 0, there you go. So it's the opposite because you're setting it up equal to 0 and bringing it over. So there's my x-intercepts. For those of you who are visual, you might rather actually graph those 2 points and find what's exactly in the middle. Would be a -1, right? Or you could say -3 plus 1 divided by 2, which is -2 over 2, which is -1. You can do it that way too. So at any rate, the vertex is -1 something, making the equation for the line of symmetry x equals -1. So let's find the y of the vertex. Plug our -1 in for x. That will give us 2 here, a -2 here. So 2 times -2 would be -4 times 2 would be -8.
Wait, do that again?
Okay.
Plug in -1.
Plug the -1 in here for x. -1 plus 3 was a +2.
Okay.
-1 minus 1 is a -2.
Okay.
So +2 times +2 is 4 times -2 is -8.
Where'd you get the -1? Oh, never mind.
Okay. So -1, -8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now let's ask ourselves the big question. This looks like it's going to open up. Should it be opening up?
Yes.
Yep, because my A is a positive. So that's kind of a way to double check yourself. Then the last thing, the y-intercept, I'm going to set my x's to 0. Wait a minute, I've already set my x's to 0 right here, haven't I? So my x-intercept is going to be, oh no, I did not plug I plugged ones in the last time. My bad. Now I'm plugging in zeros. So I'm going to 0 in and 0 in. That will give me 2 times 3, which is 6, times -1, which is -6. And the Whoa, I have those reversed, don't I?
Oh,
Because the line start grabbing it, you're like, wah! Yeah, 0, -6. 0 in the wrong place. 0, -6. Okay, now we're getting somewhere. Because we know that our line of symmetry is going to go right here. So I can get the other side of this one to make it look kind of neat. There we go.
Why do you have, two stop at the bottom?
Okay, so I'd like us to do this example because it looks a little bit different. If you would like to put it on a separate piece of graph paper, or you can flip your whole packet over, or your whole foldable over. There should be 3 graphs on the back there that are kind of for whatever you want. You flip the whole thing over. How many factors do I have in this problem? 2. I'm multiplying -x times that log. So one of the, when I'm finding my x-intercepts and I set this to 0, one of those 2 factors has to be a 0. Either -x has to be a 0, or x minus 4 has to be 0. What's going to cause this top one to be 0? If x is 0. Or if you want to multiply both sides by -1, don't do that. So x equals 0. So 0 is one of my x-intercepts. So y is 0. 0 is one of my x-intercepts. And the other one, of course, is 4. If you have a single variable out in front, then that single variable, yeah, then one of your answers would be a 0. So my x-intercepts are at 0, 0, and 4, 0. So what's going to be the x of my vertex? Go to the middle. What is that, a 2? Or I could say this plus this divided by 2. 4 over 2, 2, you can do it either way. So my vertex is going to be 2 something. And my my line of symmetry is going to be x equal 2. Okay, what change? Okay, like this. So there's my line of symmetry. Then my y-intercept, if I set my x is 0, that's going to be 0 times -4, or 0 times 0. Oh, well, wait a minute. This is on the y-axis, so this point is my x-intercept and the y-intercept. So that's really all I have. And my vertex, is my vertex? Yeah. Oh, we forgot to plug in for the other half of the vertex. So we got to plug a 2 in for the other side of our vertex. 2 minus 4 will be -2. -2 times -2 will be +4. Now, is that going to make sense? Is this going to need to open up or down? No, open down. So let's see. Will that vertex work for me? Where did I see it went? 2, 4? Yep, it's going to go up. 1, 2, 3, 4. If I had got something down here and it opened up, I would have said, done something wrong, because it used to be opening down. Okay? Yes, sir.
I'm so confused how you
Oh, no, that's fine. All right. I think we can do the next one, but I do want to go to how would we find the minimum or maximum value from factor form? Wait a minute. The value was the value. What was the value of talk a little bit about, because you had some of these on your homework last night, this is a function. So if you recall yesterday, we talked about if the question asked for a value at a certain point, then I'm saying, what is the output? Whatever comes out of your machine, which is your Y value. You put an X in, Y comes out, right? So it's the Y value, the Y coordinate of your vertex. So in a problem like this, Y equals 4 parentheses X minus 2 squared plus 6. The question says find the minimum value or the maximum value. And what I'm looking for is the output of my vertex. Just the output of my vertex. So I need to find my vertex. Oh, wait a minute. What form is this one in? This is vertex form. So vertex is staring at me. As a matter of fact, the output of my vertex is staring at me. What's the output?
I mean, I'm talking about the minimum.
Hey, what's the vertex? What's vertex?
2 and 6.
2, 6. 2, 6 is the vertex. That means in my little function machine, I put in a 2 and a 6 spit out. A 6 spit out. And this is the value that I'm looking for. When it asks for a value, I'm looking for the output. So that value is looking at me in the face. This is all it's asking for, a 6. However, is that 6 going to be a maximum value or a minimum value?
How do we know? Oh, if it's not negative, it's minimum.
Yeah. This is going to, since the A is positive, it's going to open up, which means the vertex is going to be at the bottom, which means this is going to be a minimum output. So the answer is going to be, I have a minimum value at 6. Or 6, or things like that. That's what it's asking for. It's not giving me a whole vertex if I ask for the minimum maximum value. I guarantee you, half of you will on the test. It's going to be the whole vertex. I don't want the vertex. Okay? All right. So here we are. Page 249. And the nice thing is, we have plenty of time. And it is a Friday, so you're almost done. So here's your assignment. I picked out problems that are not like you're graphing 12, 13 or something. So that's 6 graphs, I think. No, just 5 graphs. Yeah, 5 graphs. So these are pushable graphs. And we labeled your vertex minus the 3 intercepts. And then I believe these are the value ones where it wants the value and output and maximum or minimum value. These are real short. These are ones you need.